Welcome back, learners, to part 2 of complex numbers. Without wasting much time, let's start the class. So, this is question number 4 in the test, and the question says solve the equation. This is the equation. In this form, the answer is required. Alright. So, z is x plus iy. What would be z conjugate? It would be x minus iy. You should remember this identity as well. A minus b, a plus b equals to a square minus b square. Very important for complex numbers. Alright, one more thing you should remember, that if I write iy square, that is equals to I square y square. I square is negative 1, so this one will become negative y square. Alright, so these were the knowledge, pre-quiz knowledge which you should have. Now let's solve the question. Alright, pause the video, try this one and wait for the answer. So I will replace z by 5x plus iy upon 1 plus 2i minus x plus iy. It is a conjugate, that means x minus iy plus 30 plus 10i equals to 0. Very common error which students does is treat it as a quadratic equation. So what they do is multiply every term by 1 plus 2i, or they take LCM by 1 plus 2i. This is the common error which you have to avoid. Don't go that way. You will get stuck and you will get nothing. So trust me, and whenever you see any complex number in division, try to remember rationalization. What do we do in rationalization? We just change the sign, sir. We just change the sign, sir, and multiply the numerator and the denominator as well. This will become a square minus b square. Always remember, minus sign is outside, so put it in bracket. X square minus I square y square, right? And the next will be 30 plus 10i equals to 0. Easy. A plus b, a minus b. This will become 5. You can solve it if you want. See, 1 square plus 4, that is 5. Sir, y plus 4, it should be 1 square minus 4 square. No beta, this 2y. 2y का square क्या होगा बेटा? 4 times negative 1. What is this negative 1? I square is negative 1. So this will become 5. Alright. Now this multiply 5 by both. So it would be 5x plus 5 iy times 1 minus 2y. This would become negative x square. Okay. And positive y square. How positive y square? I square is negative 1. Just multiply it by negative and it will become positive. Plus 30 plus 10i equals to 0. Now, multiply these two, open the brackets, and the equation will become like this. Look very closely. 5x plus 10y minus 10ix plus 5iy upon 5. What I have done over here, I have multiplied this by both, and I have multiplied this also by both. This is how we expand the brackets. Agreed or disagreed? Tell me. Agreed, sir. And if you open the bracket, the sign changes because minus is outside. So it would be negative x square, negative y square. Negative 1 is getting multiplied by both, right? Plus 30 plus 10i equals to 0. Divide 5 by this, and this. This is 5, not 3. This is 5. Learners, this is 5. Now this will become x plus 2y minus 2ix, okay, plus iy minus x square minus y square plus 30 plus 10i equals to 0. Now real part, take the real part at one end. This and this, which is without I, is the real part, at this and this, okay. Take this at the one end. So it would be x plus 2y minus x square minus y square plus 30. This is the real part. And what is the imaginary part? Just put I over here. I'm taking I common from this. this and this. Okay, so what will remain inside minus 2x? See, if I take I common, look very carefully. So minus 2x will remain? Yes, sir. Y will remain. And what else will remain? Plus 10 will remain. All of this is equals to 0. Now tell me, the real part is also 0 and the imaginary part is also 0. See over here, 0, 0. Yes or no? So if I put real part equals to 0, it will give us x plus 2y minus x square minus y square plus 30 equals to 0. And the imaginary part, that is minus 2x plus y plus 10 equals to 0. So make y the subject and substitute in the next equation in this one. So y equals to 2x minus 10. Substitute the value of y into this one. Alright, so let's try to solve. I'm erasing something. I'm erasing this part. Okay? Oh wait. Let me erase this part only. I'm substituting. So instead of y, I'm putting this value. Okay, I'm just replacing it. This is called substitution method. So I'm doing it for you. So this will become x. See, in the place of y, I'm putting 2x minus 10. X plus, tell me, what is x plus 2? 2x minus 10 minus x square minus 2x minus 10 square plus 30 equals to 0. Alright, expand the brackets. So it will become x plus 4x minus 20 minus x square. Alright, now if I expand this bracket, it would be a square minus 2ab plus b square, right? So it would be 4x square minus 40x plus 100, 10 square is 100, plus 30 equals to 0. Now we have a quadratic equation with us. We can easily solve this quadratic equation and we will have the value of x equals to 6 and x equals to 3. For both value, we can find the value of y as well. Plug it into this one, both of them, and we will have the value of y as well. Alright, so for 6, y equals to 2, and for 3, y equals to negative 4. So if this is the case, the number would be 6 plus 2y. What am I doing? Because z equals to, we have to give the answer, right? This is the rules. Z equals to x plus iy. To find the roots, we have to equate it. Yes or no? We have to find the roots, na? Equals to 0, we have to find the roots. So we have the value of x as well and y as well. X plus iy. So this is z equals to 6 plus 2y. For the next one, z equals to 3 minus 4. This is the answer. Let's move on to the next question. Alright learners, let's try to solve this one. Find the complex number w which satisfies the equation. Alright, such that real part of w is less than 0. Give your answer in this form. Now, what can we do? The first thing that comes in my mind is assign w a value. Let's take w equals to x plus iy and let us put it into this equation. Alright, can we do that? Yes, we can. So let's do it. So what would be w star? W star would be, w conjugate would be, just replace the sign. Yes or no? So we will have w square, that is x plus iy square plus twice iota. W star is x minus iota y. Alright, equals to 1. Expand the brackets. Okay. What it would be? It would be a square, that is x square, plus 2 into x into yi plus iy whole square, that is negative y square. How, sir? I square is negative 1, I told you. So plus minus y square. So let's not write it like this because it will create confusion. Let's write it like this. All right, now it's good. Now plus multiply this by this 2xi and 2I times iy. I into I will be I square. I square 2y. I square is negative 1. Right? So negative 2y and negative will make positive. So it will become positive 2y. Try to understand it again. Try to understand it again. 2y into iy negative 2y and negative will make plus. Alright, equals to 1. Again we will do the same thing, real part. What is the real part in here? It is x square minus y square and what else? Plus 2y. Alright, and what is the imaginary part? Imaginary part is 2xy plus 2x equals to 1. Can we equate the real part equals to 1? Yes, sir, we can. Yes, we can do that. Yes, very good. Can we equate the imaginary part equals to 0? There is nothing imaginary over here. Yes or no? Just imagine. Is there anything imaginary? No. So 2x plus 2xy equals to 0. Can we take 2x common from here? 2x we can take common. 1 plus y equals to 0. Y equals to negative 1 or x equals to 0. X equals to 0. How comes x equals to 0? So 2x will also equals to 0, right? If I send this 1 plus y into division, think about it. Yes or no? Very good. So x equals to 0 and y equals to negative. Alright, let's substitute the value y equals to negative 1 over here instead of y. In the first equation, this was 1, this was 2. Alright, so what will we get if we put y equals to negative 1 in this first equation? We will get x square equals to 4 and x equals to plus minus 2. Alright, but think about it. Think about one thing. They were saying that real part of w is less than 0. Real part is less than 0. Now, plug in both the values. Try to plug in both the values into the real part. Okay? Tell me that w was x plus iy. This is the real part. This is the imaginary part. Okay? Real part is less than 0 and we have two values, negative 2 and positive 2. Which one will we take? We will take negative 2. Okay? So when y is negative 1, x would be negative 2 because it is given that real part is less than 0. So what would be w? W would be negative 2 minus I. So is the equation over? Is the answer done? Most of the learners leave the answer till here, but it is not done. X was also equals to 0, right? So let us put it into one first equation. Okay? So because it is given that real part is less than equals to 0. So 0 can also be included. So x equals to 0, correct. Let's calculate the value of y in this case. So 0 minus y square plus 2y equals to 1. We will have negative y square plus 2y negative 1 equals to 0. Alright. So we will have over here, this is y minus 1 whole square equals to 0, y equals to 1. So what would be w? W is x plus iy, x is 0. So w equals to 0 plus I times 1 because y is 1. So w equals to I is the next answer. Very good, learners. Got this one also correct. Alright, let's try to solve this question now. Solve the equation where p and z are real constants. Alright, so how can we solve this equation? This is a quadratic equation, right? So we will use the quadratic formula. X equals to minus b plus minus square root of b square minus 4ac upon 2a. Now, what is a? A is the coefficient of z square, that is 1. So I'm writing a is 1. What is b? B over here is coefficient of z, that is minus 2pi, negative 2p iota. and C is the constant term, so it would be negative Q. Alright, now let's plug in the values in this formula. So our roots would be G equals to minus B, that is minus 2pi plus minus square root negative 2p iota square minus 4 1 negative q. Alright, whole divided by twice of a, that is 2. Let's solve it further. It would be 2pi plus minus negative 4p square plus 4q. How did this happen? Let me teach you why. Negative 2pi whole square equals to, take square by square all the terms inside the bracket simply. Negative 2 square is 4. This would be p square, and this will become I square. Iota square is negative 1, so times negative 1 it will become negative 4p square. Alright, and divided by 2. Okay, can we take 4 common inside the bracket and bring it outside? It will become 2. So 2pi plus minus 2 square root of negative p square plus q upon 2. Sir, how? Take 4 common from here. So it will become 4 minus p square plus q, and now square root of 4 is 2, so I brought it out. It is 2. Okay. Divide both of these terms by 2. So it will become pi plus minus square root of q minus p square. So our two roots would be pi iota plus square root q minus p square, or pi minus q minus p square. This is your answer. Let us move on to the next part of this question. Now let's look at this question. In an Argand diagram with origin O, roots of this equation are represented by distinct points. So if we represent the roots on an Argand diagram, this is the imaginary axis and this is the x-axis, the real axis, right? They are saying that given that A and B lie on the imaginary axis, first of all the roots were pi iota plus square root q minus p square, and I can put a minus over here. So these were the two roots. This is imaginary part because iota is there. If we look closely at the discriminant or this part, if q minus p square is negative, how can I write it mathematically? That q minus p square is less than 0. Then this part will also be imaginary. If q minus p square would be positive, or mathematically saying q minus p square is greater than 0, then this part would be real. Why, sir? Because negative roots are imaginary and positive roots are real, right? In the question it is given that A and B lie on the imaginary axis, this axis, and on this axis the real part is 0. So this case will be excluded and this case will be taken. Q minus p square is less than 0 because this part has to be imaginary, and for this to be imaginary, q minus p square would be less than 0. Very good. Send the p square over here. Q is less than p square is the answer. Let us move on to the next question. Now to answer this question, let us represent the points A and B in an Argand diagram. This is the imaginary axis and this one is the real axis. Alright, and our roots were p plus minus pi plus minus q minus p square. Now they are saying given that instead triangle OAB is equilateral. Now think about it. If this is forming a triangle, if OAB is forming a triangle, that means that this part would be real now. Yes or no? Then only it will form a triangle. If all points A and B are on the imaginary axis, then it will not form a triangle, right? Because O is here, A and B, suppose A and B, then it will not form a triangle. Yes or no? So if it is forming a triangle, that means this part is real. Okay, so we have 2 points. A equals to pi plus square root q minus p square, and b equals to pi iota minus q minus p square. Okay, now listen. Let us mark these points on this diagram, on this Argand diagram. This one we will mark on the imaginary axis. Let's say this point is P. Okay, and this one on the real axis plus Q minus P square. Let's mark it over here. Square root of Q minus P square. It will take a real value, na? So I can put this point as A. Okay. Think with me, learners. Without thinking, you will not get this topic. Okay. Now, if we talk about B point, the height would be same, but it would be negative q minus p square. So negative q minus p square. X-axis takes negative value over here, right? So B point would be somewhat here. Now we have to form a triangle. OAB. So this is the triangle OAB. They are saying that it is an equilateral triangle. So we know OA equals to OB equals to AB. The magnitude I am talking about. Right? Let's mark the points. Origin is 0, 0. A point is square root of q minus p square and p. And B point is square root of q negative q minus p square and p. Don't put iota here. The common mistake which you do is you put iota here. It is already given that this is imaginary axis, so don't need to put iota. Alright, let me erase it. Okay, now see, OA will be equals to OB. If we have to find the relation, if we put OA equals to OB, it is already seen that it will become 0 equals to 0. So we cannot find the relation like this. We have to find AB first. Okay, so what is AB? AB would be OB minus OA. We have learned this in vectors. Why OB minus OA? See, from A we are coming to O. So this is AO. We have to reach from A to B, right? So this would be AO plus OB. We have to reach from A to B. We cannot go directly from here. Okay, we can take this path as well. AO plus OB. Repeat after me. AO plus OB. AO plus OB. Can we write AO as negative OA? Yes, sir, we can write. So this will become OB minus OA. Alright. So what we will do over here is we will find AB first. So AB vector would be OB, that is this one minus this part. So can we write it like this? AB vector would be, I am representing it like this, negative square root q minus p square minus square root of q minus p square. Alright, and p minus p, that would be 0. So our AB vector will become negative 2 square root q minus p square and 0. Now the magnitude of AB will be equals to magnitude of OA, or you can take OB as well. Alright, so how can we take the magnitude? Just square them and square root them. Repeat after me, square and square root, square and square root, square and square root. Very good. So I'm taking OA. So if I square OA, it will become P square plus Q minus P square. See, if we square the square root, it was like this, right? If we square the square root signs vanishes. No, we cannot say vanishes. It's like this. It's power half, and then we are squaring it, multiply the powers. So it will become half times 2 and 2 will be cancelled. So it would be q minus p square. That's what I am written. Equals to the magnitude of AB. AB magnitude would be, see, just square root it. So it would be negative 2 square is 4 times q minus p square. Yes or no? I've squared it and then I have took a square root. Okay. Square root will be cancelled. So it will be p square. They will not be cancelled. We will just multiply the powers by 2. Square both sides. We can say squaring both sides. Okay. Plus q negative p square equals to 4q minus 4p square. Okay. So p square minus p square will become 0 from here. So I'm writing it down for you. Don't worry. These will be cancelled. Equals to 4q minus 4p square. Okay. 4q will go that side. Will it or will it not? Yes or no? It will become negative. So q minus 4q equals to negative 4p square. Negative 3q equals to negative 4p square. Negative will be cancelled. Q equals to 4 upon 3p square. This is your answer. This is how you target these type of questions. These are very easy questions. If you understand the core of the topic, everything is easy for complex numbers. Alright, that's it for part 2 learners. See you in part 3 now. Don't forget to subscribe the channel.